Hydraulic models are widely used in water supply and water distribution industry. Hydraulic models are developed by specialized companies, consultants, and delivered to water utilities to support design of new water networks, develop safe operations, and to improve or optimize existing conditions. DHI WaterNet Advisor is a web-based application that allows you to access the hydraulic model everywhere, from any device, including personal computers, tablets, and smartphones. You can easily use the interface to edit the model, run simulations, and browse results. Here are its core features. Instantly access your hydraulic models. No special expertise required. Work everywhere. You can get the information you need wherever you are. WaterNet Advisor works with EPANET or equivalent software. It is very easy to use DHI WaterNet Advisor. All you need to do is to open your web browser, specify the address for the application, and provide your username and password. You will be rapidly connected to the server and start to use the program right at your fingerprints. You can use any device you want, laptops, smartphones, or tablets. Let's create a new model. Choose a name for your model and any description. Then you select the file where the hydraulic model is stored, which could be ePlanner or microurban model file, and finally specify the special reference coordinate number. Click Save when you're done and the model will be registered. The program will display the model layers in the map. You can activate different model layers using the table of content on the left side of the screen. With WaterNet Advisor, you can edit your model, run hydraulic simulations, fire flow simulations, network capacity simulations, various water quality simulations including water age, source tracing, or contaminant event. You can use the program for flow tracing, shutdown planning, and to compare simulations, display time series, comment the models to online systems, all in one place. It is very easy to work with hydraulic results. Just select any result layer from the table of contents, and it will be displayed in the map. In this case, we selected pressures. Note that nodes are color-coded by the available service pressure. In the same way, we can display, for instance, the flows layer including flow direction arrows. If you want to look into detail of the network distribution network and display how much water is entering the network from the tank, then select the pipe on the map, and the current flow will be displayed on the right of the screen. In this case, is 25 liters per second. If you want to display time series, how pressures are changing in time, select pressures and then select several nodes from the map, and then select time series. To display pressure time series, and select plot features to display the graph in the bottom of the application. Note that during the peak hours in the morning and in the evening, the server pressures reach their minimum values. In the same way, you can display, for example, node consumption. Now we can display the hydraulic pressures and node consumptions at the same time. There are several statistical layers that are created by the program. One of this is the unit head loss. Here you can see those pipes where the head loss and the velocity is too high, probably because the section of the pipe isn't not enough. Other statistical layers are minimum pressures, maximum velocities, and pressure or velocity fluctuation. The contaminant event simulation is frequently used for emergency situations. It will allow you to react straightforward. First of all, create the analysis. Now, imagine the contaminant enter the system from this node. Then, activate the junctions layer. Select the node and define the concentration. In case you don't know the concentration, use the 100 units per liter. Define the time it starts and finishes and run the simulation. The program will automatically do the changes into the model and display the results. The results are displayed in a statistical layer called maximum impact of the contamination, or you could create animated layers to illustrate how the contamination is spread through the water distribution network, and you can use contour layers for the purpose. Although in this example the contamination starts at 9 and is isolated at 11, the water has already been contaminated and will only disappear in open water connections or by flushing. With this simulation, you can also identify the dead-end pipes such as here and here. WaterNet Advisor can be used not only to run hydraulic simulation, but also to trace the network and find which valves should be closed in order to isolate certain pipes. It is easier than ever before. Let me show you how to do it. First of all, activate the layers Pipes from the table of contents. Select the pipe on the map and click Find GIS Valves. It will trace the network to identify which valves should be closed to isolate this pipe. In this example, there are 5 valves that should be closed. The first one on this downstream part of the pipe. And as there are no valves on the other end, we need to close this valve here, but also additional ones situated here. Once you identify the valves, you can run hydraulic simulation defining the time when the valves would be closed and reopened, and then run the model to see the hydraulic result of the shutdown situation. You can easily access DHI WaterNet Advisor from any device, including personal computers, tablets, and smartphones. Indeed, the program looks very nice on smartphones and works, both in horizontal and in vertical. You can select the results presentation, or you can go back to the map layers and select which layers you want to display and go back to the map, or select a different simulation or type of analysis.